What's going on, guys? So in this video, we're going to be breaking down how I built a company lookalike model. So just to give you some clarification on what a company lookalike model is, if you guys are familiar with Ocean.io, they are a B2B database, and a lot of B2B databases are trying to develop this tool where it's a lookalike search. You put in the URL of, say, your best customer or just whoever your ideal customer is, and it pretty much scrapes the website text and reads the website text, understands who your best customers are, and pretty much gets you a list of companies just like them. Okay, so Ocean.io, they charge, I think, from what I last heard, around like 10K a year for their services, and the main feature, as you can see, is their lookalike search service, right? And yeah, my friend Nick told me about this, and I was like, wow, people really paid 10K for this? And I was like, yeah, it's because they do a lookalike search. And I realized, just for me having an machine learning, AI, natural language processing background, this is just a simple embedding search that they're doing, from what I assume, right? And if you don't know what that is, I'm going to break that down in this video and just show you how my code works and yeah, how I built it. So yeah, the whole goal of this model was, given a company's website, we want to generate a list of similar companies that are just like them, that they sell the same thing. So if we give it a furniture store, it would build a list of furniture stores. Give it a law firm, build a list of law firms. SEO agency, it would build a list of SEO agencies. And how do we do that? Through natural language processing, okay? So through NLP models, we can represent the website text as a list of numbers that uniquely represent the meaning and the text of the website. So for example, so this is a blurb of text from my good friend Dylan's website, right? This actually turns into this. Like this is, and then granted, this is not all of it. This is like a 300 to 1,000 length number, like vector or list of numbers of like, yeah, 1,000 of them, right? And it represents the website's meaning. Like it literally translates this into just numeric values. So yeah, this is called an embedding. And these embeddings capture the meaning of text in a numeric fashion. So to build a company lookalike model, we build a list, a giant database of companies, just like any B2B data provider would, like Apollo, ZoomInfo, whatever it may be. Scrape their website text for every single one of them, get the embeddings for every single one of those companies, right? And then when a user requests a lookalike search of, say, like some website, like a fintech company, right? We scrape the website text of that fintech company, get those embedded, convert it to the embedding. So again, this number list, and then we just compare that list of numbers to every single other list in our database, and whichever ones are fairly similar, we send over that list. And you'll find that when you do it like this, and we call this a similarity search, by the way. So we're just finding embeddings that are similar to the one that was given to us, that's requested. And this similarity search, you'll find, is actually very accurate and filters out a lot of noise. So the next question comes is, how on earth do you even build all of this, right? So the first thing you want to do is you want to build a pipeline for ingesting millions of companies and getting their embeddings, okay? And we want to build a very scalable system to do this, because you don't want to, push one embed or one company at a time. You want to push millions, like 10s, 20, 30, 50 million companies at a time, right? So if you're not familiar with AWS, you're not an engineer, you can just skip over this, but this is fairly simple, like pipeline. Again, this is more of an MVP version. I've actually built this and sold this service myself before, and this was not it, but nonetheless, this is a nice MVP version for building this pipeline. So you just drop it into S3, have a Lambda function to parse the CSV file of the company data, right? So that's the company name, the website, the employee size, the location. Scrape the website text with another Lambda, push it to another SQSQ, and then get the embeddings of that website text, and then send it to our vector store, which is Pinecone. And in terms of actually like for generating similar companies for a request, all we have to do is build an API that, when given a company's website, along with location, employee size, we scrape the website text, convert that text into its embeddings, so get those listed numbers, and get the similar websites from our vector source. We're just doing that similarity search I was talking about, okay? So yeah, how this looks is, again, I've built this code already. So this is the data ingestion service. So we push this all to AWS, we build a bunch of Lambdas, and yeah, this is all deployed. And how it works, as I said again, all we have to do is put data into our S3 bucket. So I've already done it just for the sake of time. So I've already dropped, 6 CSV files of company data into this S3 bucket, and it represents as this. I just put them up. But yeah, so there's like 100-ish companies. And yeah, from looking into, and yeah, in our vector store, as you can see, we have 114 records in here, and this is going to be the accounts from that CSV file I just showed you, right? And look, it's the company name, company website, employee size, the location, along with its embeddings. And there's just a bunch of them, okay? And just to show you again, like just how huge and massive these embeddings are, like I just copied and pasted that. Like this is just a list of just tons. I don't like, and it's just through, yeah. So normally that's what they look like. This is actually on the smaller end because it's only 256. Often I've worked with this length of like 1,000+ embeddings, right? So, and again, every single, that's just the numeric representation of this one company's website, right? And we have one for every single company. And now to test this all, right? So we've built the database. Again, this is a smaller scale version, but we built a mini database of B2B companies with their embeddings. Now all we have to do is just hit our API endpoint and pretty much get a similarity search. So I'm gonna load up Postman. So all we have to do, we're gonna run it with this law firm right here. So just to show you what this, as you can see, this is a law firm, right? So they do what? Employment law, sexual abuse, and yeah. So all we have to do is, and again, this is just an API endpoint. So you can run this with Zapier, you can run this like with Airtable, whatever it may be, right? I'm just gonna run this with Postman just for the sake of this video. Send the request. And it's sending, and look at that, 200, we got request success, scraping and sending to SQS completed. And when that is done, what happens is it loads the actual CSV file of similar companies in our S3 bucket. And let me just, blank. It is gonna be in this one. And here it is. So let's download that and let's take a look. So and yeah, as you can see, just from looking at, let's go through these websites, but as you can see, these are, you know, attorneys, right? And look at that. And again, as you can see in our database, like there's no keywords we're using, there's no magical industries we're using. This is just purely off a similarity search off each of these long listed numbers for every one of these companies, right? We're literally just doing a similarity search on the embeddings of each of these companies, and it's getting laser targeted accuracy compared to just using some crappy LinkedIn filter, right? Again, we can go check, and again, like just, this one's pretty obvious, but let's just click on it anyways. And look at that, right? Okay, so let's do another one. So I have another one for this video, Goodwin Recruiting. So this is gonna be a recruiting staffing company, right? So they're just an agency that places employees for other companies. So let's go put this in. And as you can see for this search, we're just sticking with the United States and these employee sizes. We can tweak this to however our database fits. And then let me just, for how we built it, the company name actually doesn't matter, but we have to keep it, let's just keep it consistent nonetheless. And then send. And again, this is just some API endpoint. This could be run through, this could be hit, you could hit this endpoint through Zapier. Like you could make a type form where you collect these data points and then just hit this endpoint through Zapier, hit this API call through Zapier, and then it'll create the CSV file in your S3 bucket. Or you could even have it, we could have it even sent to you through email too as well. But again, this is just for a demonstration of this video. So let's check it out. And this is it. Now let's check out this one. So again, we just put in a recruiting agency. So let's push that out. And the Connors Group. Search jobs, find talent. You get the idea, right? So again, it's converting the website text of goodwinrecruiting.com, converting these texts into these embeddings, and then finding companies just like them using natural language processing. But yeah, that is the entire pipeline of how pretty much, and again, I'm not sure how Ocean exactly does it, but I'm fairly 95% confident they use embeddings along with other things as well to get a good lookalike search because their product is phenomenal. But this is the base underlying of how Ocean.io is built. And yeah, that's pretty much it. Thank you so much for watching this video. And if you'd like for us to build you something like this for your company, or if you have any AI/machine learning project you have in mind that can help you streamline your business, there's gonna be a link in the description below. Feel free to book a call with me and we can have a good discussion over there on what you're looking for to help out your business through machine learning and AI. Thank you so much and have a great day.